Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin. I'm going to cover matrix multiplication. So if A, defined in entry form, is an m by n matrix, and B, also defined in entry form, is an n by p matrix, then their product is going to be an m by p matrix. Defined by, A times B is equal to Cij, where Cij, or its entries, are defined by this sum of products. So the summation from k equals 1 to n of Aik times Bkj, which is equal to this, which is AI1 times B1j plus AI2, B2j, and then so on. Now, this product of sums is confusing at first until you kind of get the hang of the pattern, and I'm going to show you how this pattern works and why these things actually match here. So it's helpful to really know like the location of or the entry location. So if I say matrix C, which is the Cij, really what I mean by this is it would be kind of nice to know the location of our entries. Like for instance, this is going to be the first row, first column. So we say this is the first row, first column. This is going to be the first row, second column. This is going to be the first row, third column. So on, this is going to be equal to the second row, first column, second row, second column, second row, third column. Similarly, third row, first column, third row, second column, third row, third column. Now we know we're going to have this is I'm going to define it to be an m by n matrix. So what I'm going to have is I'm going to have m rows. So this is going to be Cm1, Cm2, Cm3. Now it's a by n, so there should be n columns. So the very last one is going to be Cmn. So that means this is going to be C1n, C2n, C3n, and then so on. Now, knowing their location is going to help us to figure out what row and column we're going to have to multiply. So really, when you're multiplying these matrices, it's going to be the row of the first times the column of the second, but we have to be careful where we are. So if I want to find the first entry, notice this says row 1, column 1 right here. So this comes from multiplying the first row of matrix A times the first column of matrix B. That's how we're going to get this particular entry. Now over here, I'm going to multiply the first row of matrix A by the second column of matrix B, and so on. So let's talk about this. If I want to find this entry, it's going to be the second row of matrix A times the first column matrix B. This is going to be the second row of matrix A times the second column matrix B. Now I've done an m by n matrix. These are smaller than that, or they're more specific than this. So let's kind of see what happens here. Let's see if we can even multiply these matrices, because in order to multiply these matrices, it says that their sizes have to be quite specific. That if this is m by n, that this n has to match this n over here. So let's see if that happens. Well, this is, I have 3 rows and 2 columns, so I have to make sure that that matches the rows of this. Well, this is a 2 by 2 matrix, so boom, those things match. Now, once those match, you can say that their product is going to be a specific size, and the size of them is going to be an m by p matrix, and you can see that there's m left here and there's p left here. So the size of this matrix is going to be equal to a 3 by 2 matrix. So since this is a 3 by 2 matrix, we know that we're going to have 3 rows in 2 columns, so I don't need this entire thing. I'm going to have 3 rows and 2 columns. Let's just erase everything besides 3 rows and 2 columns, and we'll talk about how these are going to be multiplied then. All right, so matrix C, or we'll say the product AB, is going to be equal to, well, it's going to be equal to a 3 by 2 matrix. So this is going to be 3 by 2. Well, we have it right here. And how are we going to find the very first entry? How do you find this entry right here? Well, what it says is I have to multiply the first row of matrix A by the first column of matrix B. So I have to multiply this row here by this column. What I mean by that, it's this linear combination of 2 times negative 1 plus 4 times 3. So this is going to be equal to 2 times negative 1 plus 4 times 3. Now, how do we do, say, this one over here? Well, this says first row, second column, so very similar. I'm going to do the first row here, and then I'm going to do the second column here. So when I multiply those, it's going to be 2 times 5, so 2 times 5 plus 4 times 6. Next, how do we find this one? Well, that is in the second row, first column. So this is going to be the multiplying the second row by the first column. So we're going to have 0 times negative 1 plus, a minus 5 times 3. This one. That's not a great marker, but it is what it is. So what we have is we're going to have the second row, second column. So we're going to have the second row, second column. And I am going to write that in yellow because that is ugly. So this is going to be, second row, second column, second row, second column. 0 times 5 plus minus 5 times 6. And then finally we can see this is going to be third row, first column, so 1 times negative 1, 1 times negative 1, plus 3 times 3. And then this is going to be third row, second column, so third row, second column, so 1 times 5, 1 times 5, plus 3 times 6. And when we're done, we can tell that this matrix is going to be equal to, again, remember this is a 3 by 2 matrix. And minus 2 plus 12 is 10. 10 plus 24 is going to be 34. 0 minus 15 is minus 15. 0 minus 30 is minus 30. Negative 1 plus 9 is going to be equal to 8. And then 5 plus 18 is going to be equal to 23. And this is how it's done. Really keep track of your entries and their locations, and you'll figure out what row and what column to multiply. So maybe we'll do one larger one, and that'll do it for us. So here's our last example, and just reinforcing what we did there. Now, just let's see what we have here for size. So this is 3 rows, 3 columns. This is 3 rows, also 3 columns. So I can multiply these things because those match, and the resultant matrix is going to be equal to this 3 by 3 right here. Now, if it's a 3 by 3 matrix, remember that I'm just kind of keeping track of this. That matrix C is going to be, the first row, first column, first row, second column, first row, third column, second row, first, second row, second, second row, third, third row, first, third row, second column, third row, third column. So it's going to look something like this. So when we're paying attention to how we're going to multiply these things, their entries are really going to be quite important to figure out what ones we're going to have to multiply. So A times B is, again, we said, the blue 3 by 3. So the very first entry, C11, is going to be row 1 times column 1. So 2 times 0. So remember, row 1, column 1. So 2 times 0 is 0, plus 7. So 0 plus 7 minus 15. The next one is going to be here. I have first row, second column, so I'm going to do the second column. So 2 times negative 1 is minus 2. Plus 2, 1 times 2, and then minus 3. And then finally, this says first row, third column, so first row, third column now. 2 times 4 is 8, 3 plus 3, and then plus another 3. All right. Similarly, second row, first column. So for that one, remember, this is going to be second row, first column, so 0 times 0 is going to be 0, 7 times 7 is plus 49. And then 4 plus 5 is plus 20. Second row, second column, so this is 0. 7 times 2 is plus 14. And then 4 times 1 is plus 4. And then finally the third column, so 0 plus 21 minus 4. And then third row first, third row second, third row third column. So negative 2 times 0 is 0, minus, oh, that's not right. 2 times 0, 7 and 3 is plus 21, and 5 and 5 is plus 25. Third row second column, so 2 plus 6 plus 5. And then finally the third column, negative 2 times 4 is negative 8, 3 times 3 is 9, 5 times 1 is minus 5, negative 1 is negative 5. So then finally we can finish this out to be 7 minus 15 is negative 8. This would be negative 3. 8 plus 6 is 14. 49 plus 20 is going to be equal to 69. This would be 28. 24 minus 4 is going to be 17. This is going to be equal to 46. 11 and 2 is 13. 1 minus 5 is negative 4. So if you like the content, please subscribe.